Any change in the existing level of contaminants can be called as pollutants. Air pollution. We have got different types of pollutants. One is primary pollutants, secondary pollutants, and toxic or hazardous pollutants. We say primary pollutants are nothing but these pollutants are emitted directly into the atmosphere from the source. It's called primary pollutant. For example, any industry is causing air emissions, and thereby there is a air pollution. We call it as that is the source of emissions. That is the primary pollutant. If any vehicular pollution is there, for example, any vehicular pollution is there because of movement of air pollution, vehicles, there is a dust, the emissions will be there, maybe which are lying on the road surfaces because of the movement of the vehicle, the air particulates may arise above the ground level. That is also the primary pollutants. And the secondary pollutants are nothing but the pollutants which are there, whatever it may be one or two, they undergo chemical reaction and they form new pollutant. For example, moisture present in the atmosphere, they reacts with the sulfur dioxide and sulfuric acid is formed. Therefore, that is the secondary pollutant. Sulfuric acid is a secondary pollutant. Similarly, hydrogen reacts with the chlorine, forms hydrochloric acid, hydrochloric gas. Therefore, this is HCl is also a secondary pollutant. Similarly, any pollutant which are there already in the atmosphere, they undergo chemical reactions under sunlight and they form new pollutant. One or two primary pollutants, they combine together, form new pollutant. Therefore, that is called secondary pollutant. Apart from that, we have got various the hazardous the pollutants are there, which includes like heavy metals present in the atmosphere, like mercury. If mercury emissions are there, naturally this mercury will be there as a long over a period of long time. Therefore, mercury is a hazardous toxic constituent. Hydrocarbons, because of the vehicular the combustion process, hydrocarbons are also emitted. And apart from that, we have various volatile organic compounds, polyaromatic hydrocarbons, etc. will be there. They're all they are called as toxic hazardous pollutants. Coming to the primary pollutants criteria, we call it as the criteria pollutants. Primary pollutants are mainly particulate matter. It may be size may be the 10 micron or 2.5 micron. Nowadays we are going up to the level of 0.1 micron also. Now carbon monoxide is one more the criteria pollutant. Apart from this, ozone, just above the ground level ozone is also one of the criteria pollutant. Sulfur dioxide is also one of the pollutant. Then the nitrogen oxide, oxides of nitrogen, one of the pollutant, and lead is also one of the pollutant. These are all the primary pollutants. We call it as the primary pollutants. Now, what are the sources? The sources may be a natural sources, or it may be a man-made sources, or what we call it as the anthropogenic sources. Therefore, whatever you say it is the natural sources are like like volcanic eruptions, dust storms, forest fires, pollen rains, etc. They're all the natural we call it as a natural air pollutants. Whereas the anthropogenic activities like industrial emissions, vehicular exhaust, fossil burning, and the waste from emissions from thermal power plants, mining activity, all industrial activity. That is what we call it as the anthropogenic activities. Therefore, pollution may be caused by natural sources as well as the anthropogenic sources. Then this is what we say that in outdoor, there are so many sources. Natural sources are there, industrial emissions are there, forest fire burning, heavy duty vehicular emissions, industrial emissions, non-road vehicles as well as the household or open burning of waste that causes the emissions and atmosphere air pollution into the atmosphere. Now we have, apart from this is what I told you. Any pollutants which are there present in the atmosphere, the primary pollutants, they undergo the chemical reactions in presence of sunlight, and other favorable conditions, and they form new pollutants. That is, we call it as secondary pollutants. Therefore, these are the man-made the pollutants are there, and the chemical reactions and secondary pollutants are formed, and because of the different the conditions, they may be the changing. For example, if there is a rain, naturally the pollutants which are there in the environment will be absorbed by this the rainfall, and when the monsoon is there, naturally it cleans the atmosphere. When there is a rain, naturally we can expect that there will be pure environment. There will not be any pollutants. They all will, because of the absorption action, all this will fall through rainfall drops, and that will come onto the ground. Therefore, naturally, whenever there is a rain, you can expect there is a the clean environment will be there. For example, if there is in summer, if you go to Rajasthan or somewhere, or Delhi or some Haryana or Punjab, you'll get a storm. The dust storm will come. If the storm is there, entire you'll have a lot of the air pollution. Means you will have a lot of particulates in the atmosphere. It is not good for. Therefore, depending on situations, the air pollution levels may vary from time to time, depending upon the favorable conditions. Now, of course, other than this, I don't want to discuss. There are some impacts because of the air pollution, which may cause the chronic diseases like COPD, asthma, bronchitis, lung cancer, stroke, heart disease, and also reduction in the crop production yield may reduce because of the air pollution. And also, air pollutants like black carbon and methane exacerbate the climate change also. Therefore, these are some of the impacts of the air pollution, and these are causes of the air pollution and impacts may be the pollen dust, wood burning, fire cracks, etc. also causes impact in the health of the environment, health of the humans or animals also. These are the sources that may cause impact on the human health and environment. These are the effects of air pollutants. Maybe it may cause a problem, the health impacts like on lungs, heart, brain, eyes, kidneys, etc. There will be a problem because of the air pollution. Of course, there are very highly polluted cities are there in the country, and we have got ambient air quality monitoring standards. And whenever this exceedance is there, they alert all the states to take necessary actions for control of air pollution. And these are the, I think so. If you can refer to some app is there, you want to have interaction, you want to know what are the air quality index levels of your particular city where you are living, and this index can be seen through app which is available in the anybody can have access to this. Therefore, for air quality, depending upon the air quality index, we say that if air quality index is in between 0 to 50, then we say it is a good environment. If air quality index is between 51 to 100, the air quality is satisfactory. If it is in between 101 to 200, it is a polluted, moderately polluted. And if air quality index is in between 201 to 300, we call it as a very poor quality of air quality. And the 301 to 400 is very poor air quality, whereas 400 and above, we call it as severe air pollution. Therefore, when this very poor level or severe levels are reached, air quality index reaches, generally the state governments will take necessary actions depending upon the city-based action plans for control measures. Definitely, those who are in Delhi, they may be knowing definitely about this measures taken by the graded response action plan. For if there is air quality index crosses more than 400, 300, then definitely they take necessary actions for control of air pollution in the respective cities by the state governments. Therefore, now we'll go to our topic. I don't want to touch other things. The main thing what you have to see is the burn technologies. As a part of today's topic, we have to see both burn and non-burn technologies. And we also have seen, can you hear me please? Can you hear me?
Yes, sir.
Yes, sir.
Therefore, yeah, we have seen that for management of biomedical waste, what are the components of biomedical waste management is segregation source, collection and safe storage, and safe transportation, followed by safe treatment and disposal. This may be on-site treatment or it may be off-site treatment. And also we have seen various technologies for treatment and disposal of biomedical waste. Incineration, plasma, they are fall under the burn technologies, whereas Autoclave, hydroclaving, dye, sterilization, micro, they all fall under the non-burning technologies. Like including shedding, combination of sterilization and shedding, they all fall under the non-burn technology, including chemical disinfection also is a non-burn technologies. And other technologies are like, encapsulation, anti-landfill disposal, disposal of deep burial are also fall under the non-burn technologies only. Now, we also seen that the waste management hierarchy is most preferred option is, what is the most preferred option? Prevention of waste generation and reduce, reuse, recycle has to be adopted. Then whatever the waste or even after adopting the reduce, recycle, reuse and recover options, still the waste is there. That waste has to be disposed of after pre-treatment. That is the least preferred option is the disposal into the environment, and the most preferred option in waste management hierarchy is the prevention of waste generation itself. Coming to this, the waste that cannot be recycled or reused, then and sent for landfilling at all, then final treatment options we have available is burn technologies and non-burn technologies. In case of burn technologies, I told you already, incineration and plasma pyrolysis. Whereas non-burn technology, we have thermal process, chemical processes, mechanical process, and biological process. And we also can have the non-burn technology. Microwave is there, and hydroclave is also one of the non-burn technology, and autoclave is also one of the non-burn technologies which can be adopted for treatment of the hospital waste or biomedical waste. Now coming to the incineration process, stage of incineration is, we have got waste storage and preparation. Waste has to be prepared for incineration. Then the waste means segregation should be done properly. Second stage has got the combustion, where the waste will be feeded. And third option we have got the method is heat recovery is there. But generally in biomedical waste treatment incineration processes, only in one place I have seen, somewhere near Srinagar, I have seen one plant they were recovering heat recovery is there. In other places, nowhere I have seen they have not recovering any heat recovery also. But where they are recovering heat is, they are trying to resend back to the primary chamber because of Srinagar will have very cool temperature. They are recovering the heat and that they are recirculating back into the primary chamber. That's how they are using in the form of steam. They are sending back to the primary chamber. And other methods are the stage of incineration, or we have the flue gas cleaning system should be there, and also monting should be there. After incineration of any biomedical waste, converting infresh waste into non-infresh form of waste, that is what we call it as the ash, that we call it as a bottom ash. Whatever is generated, it has to be disposed into the landfills. That is the waste stage of operation of the incinerator. What are the technologies available in case of burn technologies is open burning, incineration, and plasma pyrolysis. Anybody can say what is the open burning process? Anybody can say open burning process? Yeah, can you hear me?
Sir, openly burning the waste materials in the land, over the land.
Therefore, any waste is burned openly. Means there no any control over the burning process. Therefore, it is open burning. Simply throw onto the ground and put a fire. Whatever it burns, depending upon the calorific value, that is open burning. Means there no any control over the emissions, no control over the burning process. Therefore, it is a open burning process. It is a very old technology, and it is not at all permitted as of now. It is a banned. Open burning is not at all permitted for disposal of biomedical waste. Then second process we have is incineration, and we have got plasma pyrolysis. One and the incineration, plasma pyrolysis are one and the same, but incineration is the process where we supply high volume of air, whereas plasma pyrolysis we are going to supply the air under controlled conditions. Very limited air is supplied just for burning process, and whereas the gas is generated in the plasma pyrolysis is different, whereas gas is generated in the incineration process is different. Now, what are the principles of, we are going to look at principles of incineration, harmful effects of incineration, what are the advantages and disadvantages of incineration, and what are the waste characteristics of incineration and the air pollution control devices that can be adopted for control of. I told you in open burning, it is absolute method. There is no any control over the burning process. Therefore, the emissions from the open burning incineration process is open burning processes will be very high, and they are going to cause a lot of emissions into the atmosphere, and that causes a lot of health impacts also. Therefore, that is not permitted at all now, as of now. Now, whereas coming to the incineration, incineration is nothing but a combustion or degradation of total organics in presence of excess air. In incineration process, we have to remember excess air is supplied at high temperatures so that the whatever the waste is there, infection converts all organic and combustible waste into inorganic combustible product. Therefore, here we are going to supply excess air under high temperatures. You are converting all organic and combustible waste into inorganic incombustible matter. That is harmless compound, harmless waste that can be disposed of, and also it helps in a reduction of volume of waste and also weight. Therefore, after burning, suppose after burning we get around 10 to 20% of ash content. That means earlier it is having the 100 kgs of waste. Let us say after incineration we get about ash about 20 kgs, 10 to 20 kgs. Therefore, we are going to reduce the volume as well as the weight, apart from the converting the organic waste into organic combustible, and combustible waste into inorganic combustible product. That is ash. Therefore, render such waste harmless. Once ash is there, it is not harmless, but still it may contain harmful components, toxic constituents, because of waste itself may contain toxic constituents after incineration also. That becomes a part of ash. Therefore, ash may not be the non-hazardous waste, but it may be hazardous waste. Depending upon the type of waste that you are burning, the waste becomes harmless. But this ash may contain toxic constituents. Therefore, the waste always has to be disposed of through by recycle landfilling only. And here, the carbon generally, whatever the waste is there, that carbon and mix with the hydrogen and oxygen in presence, that is going to be converted into harmless the ash. Let us have a look at the incineration process. Can you see the slide, please?
Yes, sir.
Yes, sir.
Yeah, here, very simple thing is you have to understand the combustion process. Very simple. Combustion process, waste feeding is the system. Apart from the waste, you are going to supply air. Air is required for combustion process, isn't it? And this is the combustion chamber. Generally, the combustion chamber will have two chambers. One is primary chamber and secondary. I have not shown here. I should have shown one line here. In combustion process, there will be two chambers, primary chamber and secondary chamber. And after combustion, whatever the waste product generated is ash, what we call it, the bottom ash. Whereas the waste gases generated in the combustion process will be called as flue gas, and these flue gases will be what we call it as we are going to using air pollution control measures. We are going to control these emissions. Here we require what type of waste is required. We require air, we require waste, and we have to maintain a desired temperature so that we can convert the all combustible waste into organic waste into the non-harmful product like ash. And also there should be adequate time should be given for combustion process, that we call it as residence time, and proper circulation of air should be there. Air cannot be inadequate. If air is not available, then combustion will not be proper. Therefore, air circulation in the combustion chamber should be proper so that you can convert all waste into harmless compound. Combustion process is very simple. Carbon in presence of oxygen. Initially in the primary chamber, it will be converted into carbon monoxide. And in the secondary chamber, this carbon monoxide in presence of excess air is converted into carbon monoxide. Therefore, carbon plus oxygen is converted into carbon CO2. That is the simple process. Simple example. Here, the hydrogen molecules, whatever is there in presence of oxygen, is converted into moisture. Therefore, depending upon the constituents present in the air and type of waste or nature of the waste is going to be converted into the harmless compound, that is in the form of ash. And in the process of combustion of the any waste, some gases are generated that we call it as flue gases. It may contain toxic constituents because I showed you a simple example only. Carbon plus oxygen to CO2. Carbon, when in presence of oxygen, converted into CO2. Therefore, if there is a proper combustion, all your carbon should be converted into CO2. When you measure CO2 level here, when I measure CO2 level here, I should have very good CO2 levels, not oxygen levels. Means when you supply oxygen into the combustion chamber, oxygen will be consumed. Therefore, carbon is going to be converted into carbon monoxide. Further, it will, and in presence of oxygen, that will convert into CO2. When I measure the flue gases, I should have more CO2 level. That indicates my combustion process is very good. If I, instead of CO2 level, if I observe the carbon levels or the O2 levels, that indicates no combustion happened. This is simple technique. Any doctor is there. If you goes to a patient goes and says, I am suffering fever, he will check the temperature first. Then he will decide that yes, he is suffering from fever and all, he will say. That is the technique. Here also, in the combustion process also, if combustion is proper, then all carbon will be converted into carbon dioxide easily. Therefore, your combustion process is very proper. In presence of excess air and high temperature, all carbon will be converted into CO2. That indicates my combustion is very good. Now, apart from this, for example, if waste is having mercury, and that waste I have put into my incinerator, naturally, the waste mercury, whatever the waste is generated, ash as well as the flue gases may contain mercury definitely. Ash will have mercury content. If I measure mercury, definitely will have mercury. And also similarly, if I measure flue gases, I may get mercury emissions also into the flue gas because waste contain mercury. Some type of pharmaceuticals, it may contain cadmium, nickel, zinc. This cadmium, nickel, zinc will be there as a part of the pharmaceuticals. When I go for incineration, these cadmium, nickel, zinc also will come in the form of both emissions as well as the ash also. Similarly, you all remember when you supply air contain what? NOx, nitrogen dioxide will be there. When I use this air, apart from oxygen levels and apart from other organs, the gases, when I use this air in the presence of oxygen and a chemical reaction happens, therefore, if nitrogen dioxide is there, it may convert into oxides of nitrogen, NOx. Nitrogen gas is there, in presence of oxygen, that will convert into NOx, nitrogen dioxide. Therefore, depending upon the chemical nature of the constituents, whatever you are putting as input into the combustion chamber, because of the chemical reactions in the incinerator process, we get different types of, in excess of air, we get different emissions. Therefore, the standards have been prescribed by the Ministry of Forest for incinerator process for the particulate matter, means particulates will be there, and also NOx will be there, HCl gas will be there, and dioxin furans. That is the toxic constituents that is generated. In case if proper combustion is not there, if there is a chlorinated compounds are there, definitely you will have the dioxin furans emissions into the emission gas, flue gases. They are very carcinogenic in nature. When temperature, whatever is there, like in secondary chamber, when the gases are coming out of secondary chamber, temperature will be around 1050 minimum. If this 1050 degrees is not reduced to not less than 450 degrees centigrade in a fraction of seconds, then these dioxin furans will happen in the regenerate in the process of the flue gas system itself. Therefore, it is very essential to bring down the temperature of secondary gas temperature after coming from secondary chamber 1050 to less than 450. Then we will not accept any dioxin furans emissions. If we not reduce the temperature in a fraction of second, then definitely you can expect that this dioxin furans will happen because of the waste contains the polychlorinated, chlorinated compounds are there. Waste like plastics and other things are there. They may try to generate the dioxin furans. Definitely, if similarly, I told different compounds also will be generated in the process of incinerator process, like HCl, NOx, depending on the nature of the waste are present. And however, the combustion is complete and combustion is very perfect. We always measure in terms of CO2 only. If CO2 is high, then naturally CO2 should be in between 12 to 18% in the flue gas. Then we feel it is a perfect combustion chamber. Otherwise, if I observe only the oxygen levels in the flue gas, then definitely it is not a proper combustion. This is what I told you. This is the waste feeding mechanism, and air, waste, and the fuel. If fuel is also required, we are going to, because of in order to maintain desired temperature. If waste containing, let us say, placenta is there along the biomedical waste, which is going for incineration, then I can't incinerate. I cannot maintain desired temperature. Therefore, I require auxiliary fuel. I have to put fuel also, so that I can increase the temperature. Otherwise, temperature cannot be raised, and low temperatures I cannot incinerate the waste. Therefore, I use inputs, air, waste, and the auxiliary fuel in order to maintain desired temperature. And this is the compression chamber. Generally, two-stage compression chambers, primary and secondary chamber, and waste is converted into gas. Whatever is formed into gases form, it passes through the flue gas system. In the process of flue gas cleaning system, we are going to generate various particulates and also liquid waste. That liquid waste will go for the treatment through ETP. And after cleaning, the flue gas is free from the pollutants are emitted through stack of height 30 meters height. Whereas from the combustion chamber, we generate ash, the harmless compound, but it may contain toxic constituents. Therefore, it is treated and disposed of through landfill. Whereas the wastewater generated from the incinerator process is treated, then it is recirculated. I'm sorry, here I could not able to show recirculation. Generally, after treatment, this wastewater will go for the recirculation into the flue gas cleaning system. Here, whatever is there, it is a dual system. It will come and it will be recirculated back into the flue gas cleaning continuously. It is a continuous process. No wastewater is discharged. From ETP, whatever the sludge is generated, that will be the incinerated, or it can be generally it is dried and sent to landfill for final disposal. This is what the typical example of the incinerator process. There is the primary chamber I told you. There is the secondary chamber. There is the exhaust. The emergency exhaust is generally is provided whenever there is a problem. They try to emit through the emergency exhaust gas system, and these are the pollution control systems here. These are the pollution control systems. There is eventually followed by other the wet system, west cleaning systems. Finally, it will go through a stack of height 30 meters. Therefore, advantages are there. Accept the greatest variety of waste, treated waste and unrecognizable as ash. Significant volume reduction will be there. Energy recovery is possible, but of course, in India, nobody is practicing except one plant in Jammu, Srinagar, which I have seen. And waste totally destructed and making it harmless. Disadvantage is very expensive method, and it may generate gases like acid gases, heavy metals and ash residue will be there, and converts biological problem into potential air quality problem. See, biological, we are talking about infectious waste, but the air quality may, if it is not properly cleaned, then air quality may cause damage to the environment also. Therefore, major source of diazepurans emissions from this incinerator process. Therefore, these are the advantages and disadvantages of incinerator process. Pyrolysis is also same, but instead of excess air, we are going to send very controlled the air. Only controlled air is supplied. Very not higher quantum of air is supplied. Will not be there. Only few quantum of air is supplied. Here the plasma is we use the plasma technology to generate this the plasma torch for generation of this plasma pyrolysis process, where we can have temperature generate around 5,000 to 10,000 degrees centigrade at low temperatures, at low air supply rate. This waste will be converted here. Waste will be converted into the syngases. We call it as syngases. In this process, here syngases are generated like methane and like methane, carbon monoxide, hydrogen, and CO2. Now CO2 is okay, whereas methane and hydrogen are high calorie, they will have high calorie value. Therefore, definitely whatever the waste is there, harmful compounds are there. Definitely by plasma pyrolysis we can destruct, because temperature itself is 5,000 degrees centigrade, and the syngases itself will have some high calorie value. They in secondary chamber these act as a fuel, methane and hydrogen. Therefore, they convert all the harmful compounds into harmless compounds easily. The only difference is process same, but here controlled the high temperature is generated using the plasma torch. It's a plasma technology, and at high temperature waste is converted into the syngases, which includes like methane, carbon monoxide, hydrogen, and carbon monoxide and water molecule. And this methane and hydrogen acts as a fuel in secondary chamber. Therefore, all the whatever the waste are there, that will be properly burnt in the secondary chamber, and the gases which are coming out of the secondary chamber will be free from pollutants definitely, and will be free from air pollutants. We can with the minimum quality of air cleaning system, we can achieve these standards easily, and we can discharge. Only the problem here is advantage is we can achieve 98% combustion efficiency and volume reduction, and also solar for all types of waste, consumes less space, environmentally sound technology, toxic residue is low due to the complete combustion, does not require any segregation of waste. Energy recovery is possible in plasma pyrolysis, but only the thing is, plasma pyrolysis process is a costly affair. Plasma torch itself is not, it is an imported item, that import it, and therefore high energy is required for generation of power. Power is the problem here, constraint, and plasma torch is, of course, now we started manufacturing. I think where the plasma research institute in Ahmedabad is there, they started developing this, the plasma torch. And now we are developing, but it is a energy requirement is there. It cost of treatment is high, therefore it is not affordable. Generally, if there is a power recovery is there, if you are going to regenerate power from because of high temperature emissions, gases, then there is a possibility that we can minimize the cost. That is the only thing. Otherwise, this plasma pyrolysis is the best technology compared to incineration. Give me 5 minutes. Yeah, 1 minute, please. Yeah. One ನಿಮಿಷ ಇರಮ್ಮ be there. 1 minute, please. ಸಬ್ಮಿಟ್ ಮಾಡ್ಬಿಡಿ ಫೈಲ್ ಹೋಗಿ ಅಪ್ರೂವ್ ಮಾಡಿಬಿಟ್ಟು ಅವರು ಎಲ್ಲ ಇದೆನಾ ಎಷ್ಟು ಕ್ವಾಂಟಿಟಿ ಇದೆಯಮ್ಮ
So this is furniture. Next page.
ಇದು ಫರ್ನಿಚರಾ
Furniture.
ಇಟ್ಸ್ ಆಲ್ ಗೋಲ್ಡ್
This much is the value.
20,000 that's all
No sir, this is only furniture. And this is computer. 8,000.
that's all. We are not going to get
This is
any.
miscellaneous paper and plastic. 670.
That's all. Where I have to sign?
That.
ಮಾಡ್ಬಿಡಿ
8 you don't use.
Don't date was not put up. Why?
Because this was supposed to go before 1 minute.
ಸಬ್ಮಿಟ್ ಮಾಡ್ಬಿಡಿ ಯಾವಾಗ ಮಾಡಿರೋದು
25.
ಇವತ್ತು ಏನು ಸಬ್ಮಿಟ್ ಮಾಡ್ಬಿಡಿ ಹೋಗಲಿ. Sorry for interruption. I am in the office today. Before there is some emergency, they asked for my concurrence for some minutes. Yeah, this is the technology plasma pyrolysis, which here also we require feed input is plasma torch is the one which generates plasma in the primary chamber, where your the power supply is required to generate the high temperature using plasma torch and waste feeding. Mechanism is same, but here we are using 80 mode is the plasma torch, whereas where we require energy. But in case of incineration, the difference is waste feeding is there, air supply and auxiliary fuel. You may use fuel oil or diesel oil for the purpose of maintain the desired temperature. Here, high temperature you can maintain using the plasma, but energy consumption will be high. Therefore, cost of treatment of using plasma will be costly affair. And once in the primary chamber, air supply rate will be very minimum. I'm telling you, along with this, whatever the air is going, along with this plasma torch, that is the only air supply rate. Therefore, all the gases, syn gases generated will be combusted in the secondary chamber, and the flue gas cleaning is same, and it will be free from all the pollutants. What is the difference? We can achieve the air pollution standards definitely without any problem, but costly affair. Therefore, affordability is not there. Most of the hospitals cannot offer using this technology. And the low temperature, and what are the operating conditions of incinerators, which causes toxic emissions is low temperature maintenance. If temperature is not maintained, then definitely you cannot achieve emission standards. If residence time is not maintained less than 2 seconds, then you cannot achieve the standards. And if oxygen supply is not adequate, oxygen supply depending upon the fuel and waste ratio is not maintained properly, definitely you cannot achieve the standards. And the soil ash fallout creating steam pressure build up in the combustion chamber. Soil or ash fallout creating steam pressure built up in the combustion chamber. Incinerator slag built up, no periodical removal. If no removal is not there periodically, then we cannot have adequate combustion chamber volume reduction. It will be there if ash is not removed properly and periodically. And waste surges will be there. Poor gas, when you, for example, my capacity is 100 kg per hour. and I cannot feed 200 kg in an hour. Therefore, depending upon the capacity of incinerator only, we have to feed the waste and ensure proper treatment. Otherwise, we cannot achieve the desired the emissions. Otherwise, you will have more emissions. Poor gas mixing in the combustion chamber due to low turbulence and within the chamber. Therefore, there should be adequate to the air supply rate in all the combustion chamber. Otherwise, the combustion will not be there properly. That means there is a low turbulence will be there that causes the imbalance in the temperature that causes improper combustion. High halogen content may be there. If the content of the waste contains, if the halogen content is there, then it is going to cause a lot of emissions into the atmosphere if the waste is not having desired quality. Therefore, the waste quality also should be there in order to achieve the desired conditions. Otherwise, you cannot achieve conditions for incineration process. Toxic substance can be emitted from the incineration process if not properly controlled. It may be a toxic furangs, mercury release may be there if mercury contains, waste is containing mercury content. Emissions of other gas will be there. Formation of solid ash is there. These are the problems associated with the incineration process. Of course, these are the problems, the emissions that can be expected: dioxin furans, other organic compounds, heavy metals like arsenic, mercury, chromium, lead, cadmium, nickel, manganese, copper, and acid gases like hydrochloric acid, hydrogen fluoride, hydrogen, sulfur dioxide, nitrogen oxide will be emitted from the incineration process. Carbon monoxide is not suggested. That indicates incomplete combustion. Only CO2 emissions should be there, not the CO emissions. Particulate also will be there that causes the fire ash and all. If we not control properly, then it may cause the particulate emissions into the atmosphere. Bottom ash is also one of the problem from the environmental waste incinerators. Therefore, the impact of toxic emission from incinerators contribute to global climate change, and it causes acid rains also. Anybody can say how this causes acid rains? Anybody can expect acid rains? How acid rains may form?
Sulfuric
Sulfuric
acid
acid,
mixed with
yes.
the
Hydrochloric
water.
acid formation because of the chemical reactions. These pollutants may form. They combine one pollutant with other. Under favorable conditions, they convert into sulfuric acid and hydrochloric acid. Therefore, generally, where there is a lot of emissions are there, if you see the acid rains in the preliminary stage of rains, you will have more pH. pH value will be very high. Means it will be generally will be acidic in nature because the pollutants are there, acid gases are there. When there is a precipitation in the initial stages of the monsoon, definitely it will be acidic in nature. It may vary from 4 to 5. It is not in alkaline. It will be in acidic in nature, definitely. In the polluted areas, I'm talking, not in all areas. Of course, it causes various problems. I told you the effects, the particulates affects respiratory, morbidity, and it is known to everybody. It causes health effects, and it may cause even increases deaths also because of the cardiovascular failure, or respiratory diseases, and lung cancer. This is all known to you people. For me, not required to be explained by me. And heavy metals also presence will be there, and because of the depending upon the type of waste that you are going to be incinerated, like mercury. If mercury is there, definitely. If mercury is there, definitely mercury emissions will be there from the incineration process. Toxic gas impact definitely is acidic in nature that may cause acid rains, and also health impacts affects the respiratory and cardiovascular systems. Skin, eye irritations, and lungs problems will be there. Side effects such as cough, nausea, and vomiting will be there because of the toxic gases emissions. These are the input characteristics of the waste should have the high calorie value, at least 2000 calories per kilocalories per kg should be there. Please kindly remember these values. And the content of combustion matter above should be at least 60% above. The combustion matter should be 60%, above 60%. Non-combustion solids may be less than below 5%, and non-combustion fines should be below 20%, and moisture content should be less than 30%. Otherwise, the combustion will not be proper. Then we require more auxiliary fuel. When I am putting more auxiliary fuel means my cost of treatment will go up. Therefore, cost of treatment, in order to minimize the cost of treatment, waste should have proper the input characteristics. These are the input characteristics of the waste that you have to remember, please. And waste not to be incinerated, I told you in my last class, therefore I am not going to repeat. These are the types of equipment we use for removal of the particulates and all. We are going to use different types of filters. We call it as fabric filters, And this is the more efficient method of electrostatic precipitator is the more efficient method of controlling particulates. If you use this electrostatic the precipitators, definitely we can achieve 99%. 99.9% of removal of the particulates will be there. Apart from this, we have got wet scrubbers, means wet systems. We sprinkle waters within the system. Gas is here gas is moved through the system. Whereas the water is sprinkled from top. When it is moving, when the gas is moving upward direction, where the water is falling sprinkled from the top, it will be moving in the downward direction. There will be impingement of the water sprinklers as well as the particulates or gases that will collide with the water waters, and clean gases will come out of this. This is the wet scrubbers we use. And cyclone is generally used for the purpose of removal of particulates. Here, when gases are made to flow through this instrument, the gases will be in circular motion, and heavier particles will fall from the bottom, whereas the gas free from the particulates will be moved to the other system. The type of venturi we use for control of various the toxic gases is this is the best technology which we can use for the purpose of removal of hydrochloric, because here we are going to send the neutralizing liquid when the flow will be there through this. And here the caustic soda mixed wastewater, the water is recirculated here through this nozzle. Therefore, when it is going through this area, that will the impingement of water particulates and particulates will be there. Gases will be impinged along the water, and that will be cleaned. The gases free from will go away, and liquid waste will be collected from the bottom. Then see similarly, this method is absorbents. You can use some sort of carbon filters. We can use when the gas is made to flow through these carbon filters. The toxic constituents which are there will be removed, like including diazotherons we can minimize when it is flowing through the carbon filters. Then active carbon filter we call it as. The gases free from the pollutants will be moved through the upward direction. To use the burners should be proper. NOx removal we have to use low NOx burners, and also we have to use the different technologies there. Here we are injecting only nothing. It is only lime. I am injecting the lime only so that it is going to remove all this. Chemically, it is going to react and remove the gases, oxygen, nitrogen gases, etc. We got other methods are there for removal of PCDD, polychlorinated benzopherones and diazopherones. We have got various measures like de novo synthesis means we have to reduce the temperature from secondary chamber from higher temperature to lower temperature in a quick fraction. Therefore, for that we use generally the venturi is the best method to reduce the temperature from higher temperature, lower temperature, apart from removal of the acid gases. And we have to maintain optimized conditions, means temperature in primary chamber you have to maintain 800, whereas in secondary chamber you have to maintain 1050 is a minimum. Then only, and temperature, the secondary gases which are coming from secondary chamber should be reduced from 1050 to 450 in a fraction of a second. Then only we can avoid this formation of PCD and PCDF. Incineration, already we have learned so many things. There is a burning mixture must be raised to a sufficient temperature to destroy all organic components. We have to maintain 3 T's. We call it as 3. What we call is turbulence we have to maintain, and we have to maintain proper resist time, and also we have to give adequate time. Temperature, resin time and turbulence you have to maintain in for proper the combustion in the incineration. That is a must. We call it as 3 T's: temperature, turbulence, and resin time is the 3 T's we have to maintain properly so that we can minimize the emissions from the initial process. Here, we already dealt. I don't think so. Not equipped to explain properly here. And generally, we have got different types of the incinerators are there. Single chamber incinerators, double chamber incinerators. But single chamber incinerators not at all permitted now. Single chamber incinerator means you remember that one reaction I showed you in the first slide. Carbon mixed with oxygen. There it forms only carbon monoxide. That is, carbon monoxide means incomplete combustion. Therefore, you are not going to convert completely the carbon into carbon monoxide, carbon dioxide. In single chamber, it is not possible, but it is not at all allowed. It is not a good method to adopt for treatment at this well-off. Only we have to use double chamber incinerators only. Or in case of double chamber insulator, we got two types of system. One is the conventional primary chamber, secondary chamber, whereas in case of rotary, secondary, one more is there. In case of primary chamber, we'll have rotary kiln. I will show you. I think so. I should have some picture. I'll show you the example. These are the single chamber insulators, not permitted. Now it is not at all allowed also to use this single chamber insulator because we are not going to convert the waste into harmless compounds. It is going to be cause impact. Carbon monoxide very toxic in nature. It is not at all preferred. Therefore, we never allow single chamber insulators. It is also single chamber insulator. It has got double chamber. It is a single chamber insulator with one burner. Here there is a two doors are there, but it is not a single chamber insulator. But no APCD here. Coming to the other systems, I will show you. These also the single chamber, double chamber, but no air pollution control systems. No APCD, no air pollution control system. This is not a. It is a double chamber insulator, but no APCD. Therefore, this is also not permitted. Only double chamber system with APCD is permitted. What is that double chamber system with APCD is permitted? Here, this is the one. Primary chamber, secondary chamber, followed by APCD, and all gases are going to be emitted to a height of 30 meters height of stack. And this stack should have proper mounting provision. From here, we measure various gases we take and we absorb. And this insulator should have proper the what do you call this? We all the temperature maintained, everything can be seen here from this display board. Everything will be there. It is a tamper-proof display board. It is an automatic recording system. No, the mischievous things will happen. What is the temperature maintained? What is the secondary chamber temperature maintained? What is the exit gas temperature also? Generally, exit gas temperature should be around after APCD. The temperature will come from here. When you measure temperature here, it will be around 1050. The 1050 temperature will come down to, when I measure here, it will be somewhere around less than 100. If it is less than 100 only, you can see that it is a proper system is working. Otherwise, systems are not properly working. And what I told you, this is the rotary incinerator. This is the rotary. Here it will be in a continuous movement, rotating system. And generally, this system is used only for the higher quantum of waste. I cannot use it. Should be operated for 24 hours. If I am having adequate quantum of waste, then only such type of waste can be incinerated by rotary kiln. Here, everything system is secondary chamber onwards, system is same. Whereas from in place of the primary chamber, you will have rotary provision. It will be rotating type of drum, which will be rotating in a slow moving condition. Therefore, you will have adequate temperature maintained, and also you will have adequate residue time. By the time the waste is coming from here to this, the waste will be, you will have adequate residue time and adequate turbulence is there. Adequate temperature maintained, therefore you are converting waste into carbon monoxide, then it will go to the secondary chamber. From here, the system is same as that of the conventional incinerator, double chamber incinerator. And there are different types of, I told you, single chamber incinerator is not at all permitted. It is going to cause the emissions, lot of emissions. Even double chamber incinerator is also not permitted without APCD. Any paralytic incinerator means two-stage the chamber, incinerator chamber with APCD, air pollution control device systems. Like the two chamber provided with APCD, and rotary kiln also will have rotary kiln is also the type of incinerator. Will have a proper combustion in case of conventional incinerator with two chamber followed by APCD, air pollution control devices. Similarly, in case of rotary kiln, rotary followed by secondary chamber followed by air pollution control systems, they can meet the norms. What are the norms? Can maintain these are the norms. Suppose if the combustion, whether the combustion is proper or not, we measure only through. I told you. We will measure combustion means CO2. If CO2 is absorbed in the emission gases, then proper combustion is there. We estimate based on the CO2 level in the emissions, and generally we have to achieve 99%. Therefore, that is proper combustion. Therefore, I told you primary chamber we have to maintain 800 degrees temperature. Kindly remember these values. In case of secondary chamber, we have to maintain temperature 1050 plus or minus 50, and we have to meet these standards. I told you, particle matter 50. Oxides of nitrogen standards, we have to meet about 400. HCl should be less than 50. Dicing furans emissions should be less than 0.1 nanogram per nanometer cube. And mercury and this compound should be less than 0.05. Thackage should be minimum of 30 meters, or should be there, otherwise it's not permitted to operate the incinerator. These are the various standards have been prescribed by different countries, whereas in case of India, the dicing furans limited prescribed is 0.1. We are stringent standards have been prescribed as. Now let us sum up with regard to this the burn and non the burn technology is concerned. Small scale incinerators are not at all permitted, and single chamber incinerators are also not permitted, and they are going to cause a lot of emissions. Therefore, we are not going to allow this small scale incinerators in single chambers, and only double chamber incinerator also not permitted without APCD. If double chamber incinerator with APCD is there, that we can permit, and periodic the incinerator means conventional two chamber with APCD, and rotakill is generally permitted, and they can meet the norms definitely. Coming to this, I told you small scale not advocated and not suggested. High polluting, they may cause high pollution levels into the atmosphere. Single chamber is not at all permitted. Double chamber is also without APCD is not permitted. Pyrolytic process where conventional two-stage chamber followed by APCD is generally permitted, so that they will complete the requirements. Rotary kill is the best, but provided if the quantum of waste is high, then only we can adopt to rotokill. If the quantum of waste generation is high, then we can adopt. Otherwise, because we have to operate for 24 hours, we cannot operate only for a few hours and all. And waste energy plant is the best process, of course. As on date, nobody has adopted this method. This is as far as the one technology is concerned. If you have any questions, you can ask me. Otherwise, we'll go for other topic, please. Any questions? We'll have a break for 5 to 10 minutes. Any questions? Yeah, we'll break for 10 minutes. I think we'll come back at 5:15, please. Okay, then, if you all agree, okay?
Yes, sir.
Okay, sir.
Yes, sir.
Yes, sir.
Yeah, after having tea, we can have we'll meet, please. Okay, then. 5:15 we'll meet. Coming back to, I think so. Now, can you see my slide, please? Can you see? Can you see my slide?
No, sir.
No? Okay.
No, sir.
Okay. Actually, this is the topic requires minimum 3 to 4 hours. I cannot teach in a very short way, very difficult sometimes, very difficult. This is the topic we have to spend a lot of time. Can you see now? Can you see my slide, please?
Yes, sir.
Okay. See, one technology is concerned, mainly concern is the incineration process. In incineration process and is the controlled incineration, and second one is the plasma pyrolysis. Plasma pyrolysis, and there is also one type of incineration, but under control, where the supply rate supply of air is very less, and you are converting all the waste into syngases like methane and the hydrogen that acts as a fuel in the secondary chamber, and the complete combustion takes place. Whereas in case of the conventional incineration process, where we supply air as well as the auxiliary fuel, waste is converted into, in primary chamber, waste is converted to carbon monoxide, and in secondary chamber, at higher temperature and higher the supply rate of air, the waste is converted into carbon dioxide. Carbon monoxide is converted into carbon dioxide. Therefore, when you measure the emissions, I should have the carbon dioxide levels, higher level, that indicates proper combustion. Combustion efficiency is always estimated depending upon the CO2 levels. And so that if the proper APCD should be adopted and operated, so that we can minimize the pollutants into the pollutants emission into the atmosphere. We have got normal technologies. I think so. We have heard last 2 days we are hearing. Therefore, I am not going to explain anything. Just I will touch upon what are these. What are the factors decides on the non-borne technologies? Generally, non-borne technologies are available, but we are only the rules permits only for few categories of waste. All waste is not permitted, but still some now and then the queries are coming why you cannot adopt non-borne technologies. Non-borne technologies can be adopted for all types of waste, but there is some restriction. There is no possibility, there is no any assurance that no regeneration of the infection starts. There is no any assurance that we can dissect all the microorganisms present in the waste. There is no any assurance because of the non-borne technologies. Therefore, it is not at all reliable. Therefore, generally for highly infectious waste, it is not permitted to go for non-borne technologies. Whereas for the plastic waste, glass waste, or the other things, we are searching to adopt non-borne technologies. But as on now today in the country, only infectious waste is concerned, we are allowing only incineration only. Infectious waste is required to be treated only by the burn technology only. No non-burn technology is permitted. Whereas plastic, glass, and stainless steel, etc., we can go for non-burn technologies. Therefore, what are the factors that decide for non-burn technologies? The through input capacity, type of waste treated, and microbial infection inactivation efficacy, environmental emission and waste residues, regulatory acceptance, space requirement and availability of space, utility and other installation requirements, reduction of waste volume and mass, occupational safety and health issues, noise and odor issues, automation, reliability, level of commercialization, the technology manufacturer, technical skills and experience, cost of technology, as well as the community and the acceptance of the staff. And in the case of non-borne technologies, we have got various types of non-borne technologies. One is thermal processes, chemical processes, radiative processes, and biological processes are there. In case of thermal process, we have got low heat thermal process and medium heat thermal process. What are they? Low heat thermal process generally wet heat. The treatment system involves where we use steam as a treatment agency, where involve the use of steam to disinfect waste and is commonly done in an autoclave. Microwave, where we use microwave as a mode of treatment, and we can disinfect the waste. These are the wet heat system. In case of dry heat processes, no water or steam is added. Instead, the water waste is heated by combustion, by conduction, natural or forced conversion, and thermal radiation using infrared heaters. Generally we can see only autoclave is the most commonly used technology for non-burn technology in case of hospitals and also in the common facilities. I've seen very few hospitals in Delhi microwave they are using. Very few hospitals they are using the microwave. Otherwise, low heat, the steam-based autoclaves are generally used for the purpose of treatment of the hospital waste in the hospitals generally. Hazards are the blood spattering problem is there, spills will be there, aerosol, the solid pathogens may be, aerosols will be there. Aerosol means in the atmosphere you may have the pathogens, possibility is there. Exposure to chemicals and hazards is the problem. Hot surfaces, steam can cause burns. Ionizing radiation is there. Noxious odors may cause in the process of the autoclave process. We get bad smell. Noise pollution will be there because of steam generation using the boilers. These are we know how to operate. These are the microwave, autoclave. These are the non-burn technologies. And you may be knowing there's no necessity for me to explain to you. This we have already discussed. Microwave, the advantages and disadvantages. Whereas we also seen the dry heat sterilization systems for treatment of biometrics. Generally, we use this system for. In Delhi, they have adopted in few hospitals like including AIMS, and also near Maulana Azad Medical College also they have used this one. And that is how we have estimated at the time assessed and technology has been approved and the rules. Of course, sterilization and disinfection. What is the difference between sterilization and disinfection? Anybody can say, please? What is the difference between sterilization and disinfection?
Sir, in sterilization, even the spores are destroyed or reduced, sir.
Yeah, we can achieve 99.9999. Somewhere 0.001% is the survival of spores may be there. Where in case of complete sterilization is complete destruction is possible. Where in case of disinfection, the reduction of microbial contamination, especially the diminution of disease-causing microorganisms or pathogens, and this process is less effective than sterilization. Therefore, the disinfection process is less effective than sterilization. Sterilization is 99.999% of you can achieve. Means log 6. This is what log 6. 99.9999% you can achieve, whereas log 4 means 99.99 only. Therefore, log 4 is 99.99, log 6 is 99.9999% reduction of spores, microbial contamination. Therefore, we can achieve the complete dissection in case of sterilization, whereas chemical infection, we can achieve 99.99 only. Therefore, the sterilization is preferred than the disinfection methods. And as far as this burn technology is concerned, this is what I can say. And we can move to the other topic today itself. I don't know, these two itself is very laborious topics. I don't know. Within a short period of 2 hours, I had to cover how many chapters. The less time and more work for us and less remuneration, I'm telling you. Remuneration is very, very less from it, no. But they take more hours for most of the syllabus we had covered within 1 hour means very difficult. 4 units I have covered now. But no problem. I have accepted to convey my knowledge only. I am concerned how to impart my knowledge, whatever is there, whatever the best knowledge I can share with you people. That is my motto for me. Money is not the criteria. And let us go to next topic on liquid waste management. I'll try to cover up quickly. I thought I can cover up some questions and answers, but not possible. Tomorrow we'll see, please. Tomorrow we'll see it. Tomorrow is the last day, no? Tomorrow is my last day. I'll try to cover up very quickly within 1 hour. Then last 1 hour we'll try to spend tomorrow some questions and answers, definitely. Therefore, tomorrow, don't miss my class. Tomorrow try to be available and we will have a lot of discussion, please. Coming to the next topic assigned to me is on liquid waste management. I'll try to cover up quickly. We have got half an hour time. Let me see what best I can do. And this topic may be required, those who are taking care of the liquid waste management in the hospitals. I think so. Can you see my slide, please?
Yes, sir.
Yes, sir.
Available.
Yes, sir.
Okay. Therefore,
Yes, sir.
here you all know that the healthcare phase also generates wastewater. The content is like the water requirement in healthcare facility, source of wastewater. What are the characteristics of wastewater and the hazards associated with the wastewater? What are the rules says about the liquid waste management and treatment disposal options available for wastewater treatment? I'll try to cover up very quickly. These are the activities of hospitals which generate wastewater from the hospitals. As per the building code of National Building Code of Code 2005, there should be the at least 340 liters per day of hospitals requires the water consumption, having a number of beds more than 100, and number of beds exceeding not exceeding 100, they require about 340 liters per day, whereas number of beds exceeding 100, they require about 440 liters per day of water consumption. It also requires water consumption for the water consumption is required for nursing homes, medical quarters, and hostels per head. Requirement is about 135 liters per day. Per head is required. 135 liters per head per day. Head is mixing. Per head per day. Actually, we call it as LPCD. Liters per capita per day. 135 liters per capita per day. Water demand for visitors also should be taken into account. Altogether, the water requirement has to be estimated. But when nothing is there, we can the blindly follow the requirement of water requirement by the hospital as given by the National Building Code. Like this, a number of beds not exceeding 100, 340 liters per day, and if number of beds are more than 100, then they have to take about 450 liters per day, per head, per bed. Actually, this is now we have to estimate what is the requirement depending upon the number of beds or and what is the activity involved. And these are the various sources of wastewater generation in the hospitals, like administration ward, operating theaters, laboratories, radiology, hemodialysis, dental departments, kitchen, laundry and toilets, engineering maintenance department, runoff from paved surfaces also will be there. Therefore, you will have domestic sewage, cultures, stocks, and the associated the biologicals, body fluids, use disinfectants, floor washings, hand washings, air pollution control equipment, the wastewater from air pollution control equipments, discharge of accidents, spillages, including chemicals, laboratory, effluent discharges, fire accidents, etc. Therefore, all need to take into account. You have to estimate what these are the various sources of wastewater, which includes runoff from the paved service, patient wards, surgical units or operating theaters, intensive care units, dental departments, radiology, hemodialysis, laundries, kitchen, administration office, engineering maintenance, laboratories, bathrooms, and urinals. And these are the various types of wastewater generated, like black water sewage, that is mainly sewage containing fecal matter and urine, food residues, and grey water, that is sillage, is nothing but wastewater from washings, bathing, and laundry or technical process such as cooling waters. And storm water is mainly runoff from during the monsoon water, rainfall coming from the hospital roofs, etc. That is the storm water. You have to manage all this wastewater. It may contain contaminants like the formaldehyde, glutaraldehyde, chemicals from laboratory activities, and mercury from dental amalgam or laboratory chemicals, excessive nutrients and nitrates, pharmaceuticals, including antibiotics, will be there. Radioactive waste may be there. Infectious agents, including bacteria, viruses, and parasites, will be there from the wastewater which is generated from the hospitals. That is general we can expect. Categories of liquid waste from hospitals: infectious liquid waste, liquid contaminated with blood products, body fluids, liquid waste from oncology department, and the photogenic chemicals like hydroquine, KOH, silver, glutaraldehyde, and from X-ray units, wastewater will be there. Mercury from broken and obsolete equipment and dental clinics. Of course, this sort of things now we cannot expect because of mercury-based instruments have been, most of the people have been not using. Then mercury-based instruments like the thermometers or BP operated instruments nowadays. Only I think so mercury might have been eliminated from most of the hospitals in the country. Solvents may be there as a part of liquid waste. Therefore, we have got different types of liquid waste. Therefore, naturally, this liquid waste has to be, the contaminants are there. We have to go for proper treatment. Without treatment, you should not discharge at all. Therefore, it is going to cause environmental implications, which includes excessive nutrients, cause biological degradation, groundwater, lakes and rivers by using up oxygen, resulting in algal blooms and biotoxins. Pharmaceuticals in water may act as endocrine disruptors, and there is a problem, one problem called antimicrobial resistance, possibility of development of AMRs. Therefore, wastewater from the hospitals has to be treated and discharged. Antibiotics there could result in antibiotic-resistant pathogens development. Mercury and hematite may be there; they may poison water bodies also. If water is not properly treated, it may cause waterborne diseases such as campylobacteriosis, cholera, hepatitis A and E. I think A and B. Then schistosomiasis and typhoid fever, etc. may cause. Vector-borne disease may cause the dengue fever, malaria, and around that. Because of unhygienic conditions of the water bodies, you may develop the mosquitoes, a breeding place for mosquitoes. They may cause dengue and malaria also. Therefore, wastewater from hospitals, it may cause hazards. Therefore, there are various hazards due to microbial pathogens, hazards due to pharmaceutical and cytotoxic waste, hazards due to radioactive waste presence in the wastewater, hazards due to hazardous chemical waste also. Therefore, wastewater from the hospitals has to be treated properly before you discharge. Then it's going to cause then only it's possible. Earlier, the Environment Waste Rules 1998 has stipulated that the liquid waste generated is categorized as category number 8. That waste has to be disinfected by chemical treatment, and then only it has to be discharged into drains. That is what they have given earlier. Whereas chemical waste has to be neutralized, then only it has to be discharged into drains for further treatment and disposal. Now, the new rules have come. The new rules have been replaced. Now they suggest very different methods as per the Environment Waste Rules 2016. Chemical liquid waste has to be neutralized. After neutralization, it has to go for further treatment through various processes. It is a must. Chemical liquid waste you cannot discharge directly. All chemical liquid waste has to be neutralized. Then it has to go for into the drain. Through drain it can go for further treatment through ETP. Also, the rule says the liquid waste generated from hospital has to be complied with the before you discharge any liquid waste. That liquid waste should comply to these requirements. Like pH should be 6.5 to 9, suspension solid should be less than 100, iron grease should be less than 10, BOD should be less than 30, and COD should be less than 250. And bioassay requirement test also should be complied with. Then only that wastewater can be discharged into the drains. Or without treatment, you cannot discharge. If in case of no effluent treatment plants are there at the end of pipe treatment in a city or so, then you have to take standards. You have to comply to these general discharge standards under Schedule 6 of the EP Act by all the hospitals. They have to have their own treatment systems and they have to ensure compliance to these requirements. Somewhere this very old data may be carried out somewhere in 2012, somewhere in Faridabad, Delhi, Ludhiana, Gurgaon, Delhi, and Noida. And this is what the wastewater crisis, which I have observed when I dealt this subject between 2009 to 2017. At that time, I used to visit some of the hospitals in and around Delhi as well as Haryana and Punjab also. This is what I have observed. Most of the hospitals are having this sort of the liquid waste. Now, they are all going for treatment. Definitely, there will be some improvement. Definitely, we also have analyzed with the association with AIMS. We also have tried to measure the mercury emissions in the liquid waste. At that time, they were shifting from mercury-free based thermometers to electronically developed digital thermometers now. Therefore, at the time we have made some assessment in association with AIMS. At the time, in few hospitals we could able to measure the mercury levels. At the time they are in the transition period. Most of them they were using also, but outlet is having most of the mercury content at the time. Now we cannot observe this. Methods are direct disposal, where it does not require any investment. If a direct disposal is allowed, where there is a end of pipe treatment for a city. If city is having a treatment system, then it can discharge with the minimum pre-treatment of your wastewater. Co-treatment in municipal wastewater. Of course, hospital wastewater also can be discharged through the wastewater treated by the municipalities. That is possible, but still you have to have your pre-treatment options so that it is not going to cause any harm in the treatment system itself. On-site wastewater you can have, but you can try to reduce the pollution load by having your own treatment facilities within the hospitals. Afterwards, after treatment, you can discharge. Therefore, best option is on-site plus municipal. After treatment within the hospital, then if you discharge into the municipalities, then there will be a assurance that double treatment will be there. Therefore, but though it is a costly affair, but the most preferred option, so that it is not going to cause any impact on the environment. And direct discharge, I think so. No investment is required. This I just the other form of slide only. There's no much difference. What should be the requirement? You have to have domestic sewage, proper domestic sewage segregation, and infected the wastewater. You have to go for further treatment through. Domestic sewage can be discharged directly. If any domestic sewage is there, which is not contaminated with the infectious waste, then that wastewater can be discharged directly without any treatment as a municipal sewage. And now any infected wastewater is there that has to be treated. What are the methods we have? Anybody is having idea? Anybody is working in hospital, please?
Sir, I am in the hospital.
Do you have your ETP, ma'am?
Sir, I am working in 16 hospital. I am looking after the
I think your
quality assurance.
Chandigarh has got ETP. They got their own ETP within the hospital
We have
premises.
got
They got
ETP.
the ETP.
Sir.
Yeah. Therefore, generally, effluent treatment system should have these various types of the unit operations. First is bar screen. Bar screen means whatever the higher particles are there, leaves or any cloth materials, whatever is there, that can be removed. Then you have to have grit chamber. Grit chamber, you can remove the solids portions, any sand portions or solid portions that can be there, that can be removed. Then we have to have the provision of equalization tank. What is the provision of equalization tank, please? Anybody can guess? Equalization tank. Anybody can guess, please?
Neutralization.
The word itself is there. Yeah. That the word itself is indicates equalization.
Balance.
Yeah. Suppose the wastewater may not be generating uniformly from all the sections. It may be varying. Therefore, we have to have one collection tank where, in order to maintain uniform flow in the ATP, you have to have one equalization tank where wastewater from different sources will be coming. Once it becomes uniform level and uniform quality, then that wastewater can be sent for further unit operations. Next unit operation is the aeration tank, where we go for treatment of the wastewater by giving the proper the air supply and food by considering the food supply rate and air is supplied, so that there will be microbial activity and they try to consume all the organic matter present in the wastewater. Then when it goes to the clarifier, all the particulars are dead mass of microbes which they have consumed all this the organic matters present in the wastewater. They all die after a certain time. That will be settled all the as a part of solids. Then this settled portion after supernatant will go for filters. These filters will take care of the removal of any other the pollutants like dissolved form of pollutants in the water, that will be removed when it is going through the pressure sand filters followed by carbon filters. And finally, after treatment, this by pressure sand filters and what you call the pressure sand filters and active carbon filters, then we are going to treat the disinfecting the liquid waste. Various methods have been followed by disinfections. Either you can use chlorine gas, or I've seen somewhere in Delhi, they are using UV. They are going for UV disinfection also, ultraviolet disinfection also, but it may be a costly affair, but still it ensures wastewater will be perfect. Therefore, so nowadays they are going for RO. Even they are going for RO, and they are trying to recover the purified water that can go for further recycling and all. This is how wastewater is treated. Now, whatever the wastewater is, the solid waste is coming from these clarifiers. That is the sludge. Sludge is collected. Then it is goes for anaerobic digester. From anaerobic digesters, it will go for thickener and sludge dried after dewatering and all, it will go for the sludge cake will go for final disposal as a the generally hospital wastewater may not be suitable for the agricultural purpose. It may contain some toxic content, therefore it is generally not suggested to go for agricultural activity. It has to be disposed as a hazardous waste only. Better to dispose as a hazardous waste only. Otherwise, it may cause impact on the growing of vegetables, etc. Some sludge is also recirculated into the system so that this sludge will have microbes and they actively participate in the conversion of this waste into the inorganic compounds. Therefore, some sludge always from the clarifier is recirculated into the aeration tank so that we can ensure there will be a microbial activity, and we have to ensure proper the nutrients is should be there as a part of the things, because anyhow nutrients will be there definitely in the wastewater, and you have to give adequate air supply should be there so that you can ensure the growth of bacteria in presence of aerobic conditions. They convert all the waste or the organic matter present in the wastewater into the harmless compounds. Therefore, recirculation of some the sludge is always preferred so that you can ensure proper the aeration system process in the system will be there so that you can convert this waste into always ensure microbial activity. Otherwise, it becomes a problem. Then you have to re-stabilize, means it takes further time also. This is about the wastewater treatment system. If you want to ask any questions, this is what I told you. Now let us go into some typical examples so that you can understand further. This is what two chamber septic tank also. If somewhere in Delhi, I've seen they are using septic tank for treatment of wastewater, followed by that root zone depth treatment. I think one Christian-based hospital, I forgot that name. That hospital, they used to use this two-chamber septic tank system, but after effluent treatment by this two-chamber septic tank, that will go for treatment by the root zone depth. Means some grass varieties are grown, they put in the bed, followed by pebbles like the stones, and they remove definitely ensure proper treatment of wastewater. That is the root zone depth treatment we say after anaerobic process. These are the pre-treatment options some of the hospitals adopted, where the rule says that pre-treatment of hospital where liquid waste is required using disinfectants. Therefore, they try to create some sort of mixing tank. And here the dosage of chemical disinfectant is applied. They allow to mix it for some hours, not less than 20 minutes. Then they discharge excess flow from here into the drain. This is some sort of the systems they have created by some of the hospitals in Bangalore, and as a part of pre-treatment to ensure the requirement of this. Therefore, dispose through terminals. Other options available are you can dispose through terminal STP, where STP is available in the city. On-site treatment you can have on-site treatment, or you can discharge by if you are having your own on-site treatment system. These are the provisions suggested, of course, which you have seen now. After treatment of wastewater through on-site treatment facility, liquid waste ETP effluent treatment plant, you have to ensure tertiary treatment. You can go for pressure sine filtration, active carbon filters, and followed by chlorination before discharge into the drain or sewer. That is a must, so that you can ensure there is a proper treatment of liquid waste is made. This is a primary treatment system where the bar screen is there. They remove all the floating matters. Afterwards, it will come to the chamber from where it will go to the equalization tank, where uniform flow is maintained. Once uniform flow is there, then the outlet is sent to the outlet water is sent to the next aeration tank. Chemical treatment, where we go for flash mixing and slow mixing. Here, the chemicals are added we use coagulants, so that any particulates, any solids present in the floating way or in suspension condition, that all will come down when because of the flocculations, coagulants we are adding. When there is a slow mixing, all flocks will come together, and mass of the solids will become more, and specific gravity of the solids will be high. Once it reaches to the adequate specific gravity, they settle on their own by means of the settling. When the wastewater, you see, I told you, when you add the coagulants in the slow mixing tank, high mixing tank, they mix it. Then when it is going in the slow mixing tank, all the flocks which are in suspension condition in the wastewater, they come closer and closer, they become a solid mass, and by the time it goes to settling tank, the solid mass will be such a way that by the time it travels from one end to the other end, they fall by means of gravity. Therefore, sludge will become, they settle here only, supernatant water will flow from this settling tank, where the most of the organic matter is settled. Here, then it goes for the settling chamber. Here, this is the type of treatment system where now after the biological activity, then it's going for the clarifier. Because of the clarifier, in this clarifier, all the wastewater having high the specific gravity more than water, they all will settle at the bottom, that is collected from bottom, whereas the supernatant will flow from these outlets. Then from where it will go for further treatment, that is tertiary treatment. The settling system, how it happens, I just try to show you some example only. Now, because of lack of time, I cannot take much time. There's a settling tank where how the settling takes place. Flow will takes place by the time it reaches the outlet, all when it is moving in upward and forward direction. There are different types. There is a circular type, there are rectangular type, this is a rectangular type. This is a circular is different. For in case of the rectangular type, flow it takes from one end to the other end. When it is moving from upward direction, downward direction, because of the gravity, they all will settle. That will be collected from the bottom, but a supernatant will go from outlet. This is a circular type of tank. Here system itself, settling will take place here itself because of the slow movement of this rotor. Then the overflow, supernatant water will go from outlet. Then further it can go for the secondary treatment, where settling tank will be there. Biological activity also can be ensured. Then aeration, where you maintain proper aeration. The system, so because of the biological activity, whatever the organics are there, they will be converted into the harmless compounds because of the microbial activity. After aeration tank also will the wastewater will go for secondary settling tank. Whatever the mass is there, dead mass of microbes, microbial activity, whatever is there, biomass, what you call it as biomass, it will settle on its own. The supernatant will go from the outlet to the tanks. It will have, and after that the wastewater will go for the sand filters and the presence of active carbon filter. From here, all the whatever the dissolved form of any odors or colors or suspended solids are there, that will be removed from this the filtration process. We have got pressure sand filters. The pressure sand filters are used, and this is a method generally we can follow. And these are the active carbon filter, where water will pass through the active carbon, whatever the dissolved form of any the pollutants are there, that will be removed from the active carbon. Even you can remove the odors and all, and purified water will come through these filters. You all know about these filters and all. The complete system of the treatment system, sewage treatment plant, I'm telling you. Therefore, there is a bar screen, then equalization tank, then the water will go for aeration tanks, then clarifier. After clarifier, it will go for clarified water. It will go to the various filters, pressure sand filters, active carbon filter. Filter water is this one. Then it can go for discharge. Before disposal, we have to go for the chlorination. Then after chlorination, it can discharge into drain. Otherwise, treated water can be used for the purpose of any. Before chlorination, if you want to reuse it, if it is meeting the requirements for use of agricultural purpose or any land filling or land application, it should meet some requirement. Then only that treated water can be used for the purpose of any other activity. Now, whatever the sludge is there from clarifiers, it is collected, and through filter press, the water content is removed, and dried sludge is taken to the drying bed, that can be disposed of as a hazardous waste. Or generally, the STP sludge, you can expect there will be some sort of hazard consciousness, because we don't have proper systems. All industrial wastewater is also discharged through drains. Therefore, whenever the wastewater is going through STPs, it may contain hazard consciousness. Therefore, sludge is not generally fit for manure purpose. That has to be ensured. After meeting any quality of manure, then only that sludge can be utilized. This I would just want to show you the different forms. This sort of alternate arrangement should be there. In any ETP, we have to have two systems. In case of cleaning of one unit, other one will be in operation. This is the only flow chart I just want to show you, just for example. Flow chart, this is what I just want to show you, some of the hospitals which they have adopted. And these are the systems which I have seen when I dealt this subject. Like, the HAL, they got a huge treatment plant where they're treating the wastewater. And these are the treatments, wastewater treatment systems which I have seen in Gurgaon. I think so. It is a Fortis Hospital, I remember. They got their own, the only collection tank. From there, they got fabricated ETPs are available. They require less space. Don't think that we have, no, depending on the type of wastewater generation, we'll have the space requirement is there. And depending on the type of wastewater generated and the quality of quantum of wastewater generated, you can go for fabricated ETPs also. They are available. One can adopt and you can ensure proper treatment. This is what I said, St. John Medical College and Hospital in Bangalore. And this also has got some sort of the STP, the treatment plant, where they are ensuring proper treatment. Of course, there's some of the hospitals where they are adopted HL hospital. They are having the proper treatment systems. One of the COMFST, which they generally have this sort of treatment systems by the COMFST operators. This is about liquid waste management. I hope so. I could able to cover up within the given time of, I think so, 5 units I have covered today. I hope so you have taken into account and you have understood. If any problem is there, still, this is my contact details. If you are having any problems, you can talk to me. Of course, now I am at working at CPCB Bangalore office. I am here. I am working as a region director. Earlier, I used to work in CPCB Delhi office as a additional director. Now I am here as region director. These are my contact details. Anybody is having any problem, you can talk to me. You are free to ask me anytime. No problem. Any questions? If you have any questions, you can talk, or otherwise, you can conclude this session today. I hope so. I know it is a very, I hope so. It is a lengthy talk, huge topics covered. It is entirely science. Operation of incinerator is not a simple job. It is like a science. When you're treating waste, not simply discharging, throwing waste into the primary chamber. No, it is like a science. We have to operate the incinerator in a systematic way so that we can ensure compliance to the emissions. Otherwise, not possible. Any questions? Then you can ask. No questions? Any questions, ma'am? No questions. I think this is very, it is actually, it is completely science actually. Your mic is off, madam. Your mic is off. Yeah. Actually, it is a science. It has to be explained in at least, I require minimum 6 hours. To explain the incineration process itself takes 6 hours time. If you have to teach clearly. For me, no slides are required. I can teach like that. But the given time is 2 hours. They told me to cover up 5 units. Very huge. I know that. I try to explain in a simple language for you people, so that you can understand. For your, when you look at some question paper tomorrow, definitely I will spare about half an hour tomorrow. I'll try to complete topics quickly, and half an hour we will use for interactions. And try to attend tomorrow's class. I think it will be useful for you.
I missed your class today, sir. I got busy with office work, so I couldn't free myself.
Tomorrow, try to attend. Tomorrow topics are very small topics. I'm not going to teach anything because of what are the rules are there in what are the various international treaties are there. That is, I won't take much time. And secondly, what are the various rules are followed in different South Asian countries. There are no much rules in any other country, as far as my knowledge is concerned. Only we are having, and I think so Bangladesh, they have simply copied 86 rules, 1989, 1998 rules. They simply copied into Bangla and they are adopted. If you go to Nepal, no rules. Bhutan, no rules. Sri Lanka, no rules. And there are no any rules in other countries. But I think so, our rules are there at par with the other countries. And we have gained a lot of energy, a lot of experience in the field also. And we have got very good rules. Now only there is a sporadic instance of improper management of hospital waste. Otherwise, we have got very good infrastructure for hospital waste management is concerned. There is no such problem. Now and then there are some illegal hands are there that they are creating nuisance. Otherwise, we got infrastructure all over the country, except in northern states. Therefore, looking forward to you all. Tomorrow, don't miss my class. Tomorrow, I'm going to spend at least 1 hour with you people on discussions where I'm going to show you a lot of questions and I will try to explain in case if you're not in a position to provide your reply. Otherwise, I will explain myself. Okay. See you all tomorrow. and sharply by 4 o'clock, please. Okay then. Thank you all.
Thank you, sir.
Thank you, sir.